98 validate binary search tree. In this question, we have to check if the BST is valid or not. So BST is defined as left subtree of a node contains only nodes with keys strictly less than the node's key, and then the right being greater than the node's key. So we have 2, so everything on the left should be less than 2, and then everything on the right is greater than 2. So it is true. But when we look at example 2, which is what we have here, left is great, smaller than 5, and then this 4 is not greater than 5. So it's invalid, so it should return false. To make it work, we have to change to 6. But it still will return false because everything on the right should be greater than 5. And then this one should be greater than 5, but it should be smaller than 6. So it might be 5.5, but if it's 7, it should be 6, and then this right should be greater than 7, so it should be 8. Now it's become a valid BST. So it looks like every node has their lower and upper boundary, because this one should be greater than 5, but it should be less than 7. So let's create a very generic BST, and then we can write down the boundary for each of them. And based on the boundary, we can work out how we should approach the question. So what's the boundary for A? Well, it doesn't really have any, so it has like minus infinity to plus infinity. What about B? The lower boundary should remain the same, but it has to be smaller than A. And then in case of D, the lower boundary also remains the same, but it has to be smaller than B. In case of B, it should be greater than B, but smaller than A. And then C has to be greater than C, and then has no boundary. And then F, it has to be smaller than C, but greater than B, so A, so AFC, and then that will be C, G, infinity. So what we're going to do is we're going to look at the left nodes. So left, this is left of A, and then this is left of B, this is left of C. So in case of left nodes, so we said there are lower and upper boundary. Let's have a look at the lower boundary. So it's minus infinity and then minus infinity, and this is so basically it's getting the lower boundary from the one of the parent. So F has a lower boundary of A, but it's coming from the lower boundary of the parent. So from parent. What about the upper boundary? So A, which is the parent node, and then B, which is the parent node, and then C is the parent node. So it's the parent value. Let's have a look at the right nodes. So right one will be these, and the lower would be B, which is the parent value, and then lower is the parent value, lower is the parent value. So it's parent value, and then let's have a look at the upper boundary. So it's coming from the parent, and then it's also coming from the parent. And no, what am I doing? It should be this, coming from the parent, and then this is also coming from the parent, and then this is also coming from the parent. So from parent. So what we can do is we can use these boundaries and then recursively call the function, check if the node satisfies these boundaries or not. So we're going to use DFS. So it will be private boolean valid. So this needs to have the node and integer of lower boundary and integer of upper boundary. The question is, how should we represent this minus infinity? I'm just going to set it to null. That's why I use the integer rather than int. So return valid, initially put root and then null and null. So what we're going to do is we're going to return a valid node.left. If it's the left one, we are getting it from the parent, which is just propagating the lower variable, and then the upper boundary is parent's value, so node.file. And then there should be another valid for node.right, and the lower boundary is the parent's value, and then upper boundary is just propagating the whatever the parent's upper boundary is. And suppose this one didn't work out, so it returns false, but everything on the right was correct, so it returns true. It should be false. So true and false should return false. So the operation we're looking for is AND. And for every node, we have to check these boundaries are satisfied. So if lower is not null and node.file is less than or equal to lower, we return false. Again, check the upper boundary if it's not null. The reason we have lower is not null because for these ones, if they are null, there's no point in checking. Likewise, if the upper boundary, if they are null, there's no checking the upper boundary. We just need to check the lower boundary. Return false. So if these conditions are not satisfied, which is what we are given in the question, we have to return false. And say we reach the recursively went through all the checking and then got to the null. That means these false wasn't called, so we can simply return true. Okay, let's run the test. Okay, what is going on? If lower is not null, oh, what's going on? All right, let's submit. Okay, that's it.